What's up, 7th graders? It's Mrs. Talati here representing Mrs. Servati with the last section of Module 7, which is 7.3, Solving Two-Step Inequalities. Your essential understanding for today is I can solve two-step inequalities. As you can see in your note taker, your key term section is blank. But what I do want you to do is I want you to write down this equation, 2x plus 7 equals 11. Okay, so write this down. And all I'm going to do is quickly refresh your memory on solving a two-step equation because it has the equal sign, right? So I'm going to start out by, remember it was PEMDAS backwards. So I'm going to cancel out the 7 by subtracting it from both sides. Bring down my 2x equals 11 minus 7 is 4. 2 times x equals 4, so I'm going to undo the 2 times x by division of 2, and x equals 2. So just to recap, this is a one solution, and it only has one solution, okay? So then now, if I give you that same type of equation, but now instead of an equation, I'm going to write it as an inequality. So I'm going to write it as 2x plus 7 is greater than 11. I'm going to solve it the same way. So I'm going to follow my PEMDAS backwards. I cancel these out. 2x is greater than 4. I divide by 2, and now x is greater than 2. Now remember, a couple things. When we graph this on a number line, we can emphasize the 0, the positive 2. This will be an open circle, and it'll go to the right. This now means, and I'm just going to write a couple examples, that x can be, let's say, 3, 7, 9, right? So we compare an equation with one solution, we get a solid answer, it's black and white, to an inequality that we now have a range of numbers in our answers, and it can be on infinitely. Meaning, once I go past that 2, it's 3 and beyond, including positive fractions, decimals, and whole numbers. So again, I just did this to, again, compare the two, but to show you that the steps are the same. So take a look at the first example. This one says that Serena wants to complete the first 3 miles of a 10-mile run in 45 minutes or less, running at a steady pace. The inequality, and I'm just going to write it, oh, it got cut off. So let's do this first. You need to add in the 10 here. We need to know that it's a 10 miler, right? So 10 minus 0.75p is less than or equal to 7. So what I feel like more than this got cut off. Hold on a second. Oh, it's because we have, okay. So now what I want to do, you guys, is I want to emphasize, remember when we first learned how to write two-step equations? One of the biggest things that we did was we were able to label the different parts of the equation. So we're going to kind of do the same thing here to emphasize where these numbers came from. So if you guys look at it, it's the 10-mile race, okay? So this is very clear. This is the 10-mile race, okay? The 0.75 is the 45 minutes. And please write this down, which is really 45 out of 60, which reduces to 3/4, which is also 0.75. So just in case you were wondering where that 0.75 came from, it's because they took the 45 minutes out of the 60-minute hour, reduced it down to a fraction, converted to a decimal. And then the P is going to be the pace at which she runs. And she wants to find out her pace, sorry, and this is the number of miles left, right? Because she already ran the 3 miles of the 10-mile race, okay? So again, understanding where this came from. And then is less than or equal to. Less than or equal to also could be at most 7. Because that's her goal, right? The 10, so she only has 7 miles left. So then I'm just going to rewrite this over here and emphasize again what I just did in the key terms is that we're going to solve this same way we would an equation, but now it's an inequality, so I'm going to subtract the 10 from both sides. These cancel out. I bring down my negative 75/100 p equals a -3. I'm going to divide this both sides by the negative 0.75. And then remember, the 3 is going to go on the inside when we set this up. So we have the 3. Just to recap our rational numbers, I'm going to move this 2 places to the right, which means I'm going to add 3 here. 75 can't fit into 3, 75 can't fit into 30, and then 75 fits into, see if it goes 4, there's a 0, 2, perfectly, okay? So our pace is going to be, oops, and I put an equal sign, bloody, less than or equal to 4. Now we have to be able to translate that back into, let's see, I'll do, man, again, you guys, my spatial reasoning is off because quickly I'm just going to graph this answer. So it was good that we ended up with a positive, so pay attention that we had a negative divided by a negative, which is a positive 4. Our race pace has to be a positive number because we can't run backwards in time, right? So then this is going to be a closed circle, and it's going to be less than or equal to. So then we can just write this as a sentence. Serena has to run at a steady, I just want to point this out, you guys, for those of you guys that run, this is insane. I would almost call this not real life, right? 4 miles per hour. I mean, that's like a dead-on sprint. So I think they maybe should have used better, I don't know, better numbers, but in this particular problem that we solved, Serena has to run at a steady pace of at least 4 miles per hour. That is fast. I mean, I'm just telling you guys right now, as a runner, that's really fast. I want her on my team, right? Okay, so check it out. We took it from a 2-step, we broke it down into the meaning of each part of that 2-step. We solved it, we graphed it, and we wrote our sentence. All the parts you need in order to solve a 2-step inequality. Okay, so next problem. At gas and wash. Gasoline sells for $4 a gallon and a car wash costs $12. Erica wants to have her car washed and keep her total purchase under $60. Here's their under. The inequality, now this one's going to be a little bit different. So we have 4G plus 12, and again, I'm just going to break this part a little bit. So we have the cost per gallon. We have the number of gallons. We have the car wash cost. We have the under, is that the word she used? Where's it at? Right here. Under, so less than, and this is the total cost. Okay, so this one is a little different because it gives you the inequality, right? And then it says, use the inequality to find G, the number of gallons of gas she can buy. Determine which of any of these values is a solution. So now listen, I'm going to tell you that there's 2 ways to solve these. I'm going to show you a method that we haven't really emphasized as much, which is called kind of the guess and check. But what I'm going to do is I'm going to take this 4G plus 12 is less than 60, and I'm going to test out this G that is 10. So instead of the G, I'm going to put in a 10, plus 12 is less than 60, 4 times 10 is 40, plus 12 is 60, and then 40 plus 12 is 52, which is less, I don't know where I wrote 2, less than 60. Okay, so this is a true statement. So it says determine which of any of these is a solution. So 10 is a solution because it's a true statement, right? So then we're going to test out our next one, which is 4 times 11 plus 12, which is less than 60. 4 times 11 is 44, plus 12 is less than 60. 44 plus 12 is 56. Is that less than 60? Yes, that's a true statement. So we can say again, this is another true statement or another solution. And then the last one, I already know what some of you guys are thinking too, especially my kids. 4G, nope, 4 times 12 plus 12 is less than 60. 48 plus 12 is actually 60. And because this does not have the equal sign, this is a false statement, right? So no, 12 is not. Okay, now I know some of you are thinking, why didn't she just solve this? which you can. I just wanted to throw out the yes and check method. So what I'm going to do is I'm going to go back up here, erase all this, because I'm running out of room. Again, I've not given myself enough space. If I solve this and I subtract 12 from both sides, cancel this out, I get 4g is less than 48. Divide by 4, and my solution says that g has to be less than 12. So right here, you can identify the yes, yes, and no, right? Because 12 is not less than 12, it's equal to. So that's two ways you could solve these. If given the solutions, you can plug and chug or check your work, or you actually solve it and then be able to interpret what that solution says, okay? And then again, this is pretty easy because you guys have 1, 2, 3 problems. On 4, let's go this route. Let's see who's paying attention. This one I want you, I'm going to call it plug and chug, because I think that's the term Cervantes used. Plug and chug. This one I want you to solve and interpret the solution. And you can do both with both, just so you're familiar with what that plug and chug looks like, because come like SBAC time, there may be times where you just want to plug it in and see if the solution works. All right, you guys, have a great day. Complete the note taker, and we'll see you tomorrow.